So here is my picture. Let me draw a part of the circle. Here is X, here is Y. This is theta. Okay? And let me choose this length, the radius of my circle, R equals 1. Why? To make life easy. Okay? So I don't have any R's around. R is not relevant. This means this length here is 1. And this length here is just cos theta. Clear? Now let me change theta. Let's say theta increases by a small amount, delta theta. Let me draw that in a different color. So this is delta theta. And this whole amount is, the purple one is, this angle is theta plus delta theta. Okay? So the value of this point is cos theta. And the value of this point is what? Let's look at this figure now. I want you to follow this step by step very slowly and really understand all the steps. You can all get it. Okay. Now I have this triangle. This side was 1. And so this length here is cos theta. All right? Now I have a new triangle, this one, whose angle is increased by a small amount delta theta. So this is theta plus delta theta. And this length here up to this purple point is how much? Cosine of theta plus delta theta. Does everybody get this? For each triangle, the x leg is just the cosine of that angle. So that means if I draw a circle with radius 1, for any angle theta, I can just take my ruler on the x-axis and read off numerically the value of cos theta from the axis. It's an analog computer for calculating cos theta. Okay? So let me write this in purple. This new point is cos theta plus delta theta. Now, in taking a derivative, what do I want? I want to see how this cosine, this length along the x-axis, changes as theta changes. First, answer this question. I have increased the angle theta to theta plus delta theta. Does the cosine become larger or smaller? Smaller. Cos of theta plus delta theta here is shorter than the cos of theta. Is this clear? Now what do I want? Of course I want to calculate from this figure the following. I want to know cos of theta plus delta theta minus cos of theta. This is what I need in calculating derivative. How much has this cosine changed? All right? Now, can I see that in the picture? Yes. It is this length. Right? So let me also write that down. The change in cosine theta is the new value of cos theta, which is cos of theta plus delta theta, minus the old value of cos theta. Okay? And geometrically, in this picture, I can read off the numerical value of this by just measuring the green segment here. Is this clear to everyone? Okay. Now the trick starts. Now I will do some drawings geometrically to figure out how much that length is in terms of theta and so on. Okay? I won't write many symbols just to keep the picture simple, so I'm using color code. So the green line equals the other green line. Yes? I'll complete this triangle here. This length is approximately equal to delta theta. Why? First, this green sided, green and purple little triangle here, this side is a straight line, but when the angle is very small, which it is, okay, when delta theta is very small, the length of this straight green line is approximately the same as the length of the arc in black. The length of arc on a circle is equal to the radius of the circle times the angle at the center, provided the angle is in radians. Okay, that was the definition of radian. Now my circle has a radius of 1, so the length in meters of this little black arc facing delta theta is just delta theta. That means if you really take a little string or rubber tape meter, put it there and read off in centimeters or meters, you will read the value of the angle in radians. Is this clear? This is a tricky point, so maybe some of you didn't understand, and I will explain it again. Does everybody get it? Right? If the angle is small, straight line almost equals the circle piece, and that piece is just the radius times the angle in radians. The radius is 1, so this length is delta theta. Maybe it is 0.0125 radians. You can read it off with your tape meter. Yes? Okay. Now I have this angle here.